Hello everyone, and this is Prasad Kulkarni from Solapur, Maharashtra. Today we are going to discuss about the classification of robots and classification of automation. So, in the previous lecture, we discussed about what is automation and how we are using in industrial robotics. So, the automation is a method of using a wide range of computer and machine-aided tasks to help improve the productivity and create easier ways to do the business. Different types of automation are commonly used in different types of industries. Uh, for an example, automated meters and pumps assist consumers daily when they pump their gas. In industrial setting, different types of automation provide benefits to companies, including decreased part cycle time, higher quality products, and increased worker safety. So how do we classify those kind of automations here? So basically there are three types in which we classify the automated systems, manufacturing systems obviously. So the first one would be fixed automation, the next is programmable, and the third one is flexible automation. So we can see one by one all these automations, the means how we can define those automations and what are the typical features of that automation we'll see. Now the fixed automation is the first one. A manufacturing system in which a sequence of processing or assembly operations is fixed by the equivalent configuration. There are typical features. When we just read out these features, you will automatically know that it's a fixed automation. The first one in features are suited to high production quantities, high initial investment for custom engineered equipment, high production rates, relatively inflexible. Inflexible, the word inflexible means a lot here because we are not changing anything, we are just keeping it as it is. There is no certain change in the sequence of operation, sequence of processing. That's why we are calling it as inflexible in accommodating product variety. Obviously if we are not changing the sequence of operation, the sequence of processing, then definitely you will get a similar kind of product all the time. There will not be any variety in the product. So now the programmable automation. What is programmable automation then? A manufacturing system designed with a capability to change the sequence of operations to accommodate different product configurations. Now there are features of this automation also, and high investment in general purpose equipment, lower production rates than fixed automation, flexible to deal with variations and changes in product configuration, most suitable for batch production. Yes, batch production. In the previous case, only one unit you are means in the fixed automation, only one unit you are going to manufacture all again number of times the same product you are getting. But here a certain batch you assign and you define that these kind of operations are performed on this particular product. So similar product I can manufacture, I can produce. So that's why it is suitable for batch production. The next one is physical setup and part programming must be changed between jobs. Means here between jobs, when we say, that means between the batches. Now the last one is, that is flexible automation. Flexible automation, it's an extension of programmable automation in which the system is capable of changing over from one job to the next with no lost time between the jobs. There is not at all time is losing when we are doing flexible automation. The variety of operations you are doing on the same job, you can interchange the operation sequence also. It is permitted in this case. Now the features, high investment for custom engineered system. Now one thing we must know that in typical features in these three types of automation, one thing is common, that is high investment cost. Why it is so? Because whenever whenever we say automation, that means we are eliminating the human intervention and we are bringing there some machines, some tools instead of human being. That's why the machines cost more, and a person, if he is doing something, if she is doing something, there will be a range under that only the person works, but the machines, they can work continuously. That's why there is a more, whenever the money comes, there is high investment in automation. Now the second feature, that is continuous production of variable mixes of products. You can mix the product variables, variations, you can make how many variations you want. That's okay with this flexible automation because we are designing the complete setup accordingly. Now the medium production rates. Production rate is medium, not like it's not more like fixed automation, it's not less like programmable, but it's medium. Flexibility to deal with soft products variety. Yes, that's the same thing. Now the product variety and production quantity for the three automations. The graph here, it will show you that this is on y-axis, that is product variety, means the kind of variety we are getting, that is easy to understand, and on x-axis the number of products, production quantity. Now if you see at these rectangles, the first one is programmable and the last one is fixed one. Now obviously by the diagram itself, by the graph itself, you will know the everything, that is product quantity and product variety, is moderate in case of flexible automation. There is very less product variety in case of fixed automation. Why so? Because we are not allowing to change the sequence of operation in the fixed automation. On the other hand, the product variety in programmable automation is more. Why? Because we are giving a lot of freedom to the process sequence of processing. That's why we are getting product variety. Yes, we are giving product variety, but is there any effect on the product quantity? Yes, it is. When you say in fixed automation, it's nearly about 1 million products you can manufacture. It's just a vague digits just we are putting here, just to make you familiar with what in which manner these three automation systems work. So the fixed automation, the product quantity is too much but the variety is less. But in programmable automation, whereas the variety we are getting is more, but the quantity is very less, and the compromise in between these two is flexible automation. Now before going to the classification of robots, there are some points we must be knowing regarding the differences in these. And what are those points then? We'll just see what are the advantages. Comparatively we can see what are the advantages, what are the disadvantages of. First we'll go with fixed automation. Fixed automation, there is when means okay, these are the types, but when we can use it, in which scenarios, in which cases we will use it. So on that only, this tabular form we can in table it's written. So fixed automation, when it is considered when high demand volume, long product life cycle, in that case the fixed automation is used. Now what is the advantage in that? Maximum efficiency and low unit cost. So there must be a disadvantage, large initial investment. Yes, it's there all the time, like I said previously, large initial investment and inflexibility, it's not flexible, the sequence and all. Now the programmable automation, in which scenario we can use this programmable automation? Batch production and products with different options. In those cases we can use this programmable automation. Advantage of programmable automation: flexibility to deal with the changes in product, low unit cost for large batches. There must be a disadvantage. Yes, it's there. High unit cost relative to fixed automation. We are saying unit cost, not the complete product cost. The unit cost is very high compared to fixed automation. And a new product requires long setup. The setup is formed according to that batch only. If you are changing the product, if you are changing its dimensions and all, so in that case it will take much time. Now flexible automation, when do we need to consider it? Low production rates, varying demand, short product life cycle. Advantages: flexibility to deal with design variations, customize products. A large initial investment is the disadvantage all over again. Now that's all, it's all about the classification of automation. Now we'll go to the classification of robot. The robots are classified in many ways, but we'll see just one by one each of it. Now on which basis the first kind is classified? On based on the robot arm configuration. That is, in that there is Cartesian coordinate, cylindrical coordinate, polar coordinate and jointed arm configuration. These are the 4 types under robot configuration. Then one more based on power source. Power source means the drive, means which drives that robot. On that also the robots are classified, like pneumatic robots, hydraulic robot and electric robot. Again, the third one is based on path control. Limited sequence robot, point to point control, path control robot. Now amongst those 3 categories, we'll just go through Cartesian. The first thing that is based on robot arm configuration. Now the first one in that configuration is Cartesian configuration robot. This diagram is giving you complete idea how the Cartesian coordinates work. So this one is y axis, this is z and this is x. So in these directions only our robot is going to move. Okay, and these 3 axes are perpendicular to each other, means they are at right angle to x, y, z axis, these all 3 axes. Now the x coordinate axis may represent left and right motion, y coordinate may represent forward, backward and the z coordinate upward, downward. Example for that is overhead crane movement. Many of the industry we have seen the things moving from the heavy things which are moving from here to there in that shop floor. Those are by using this Cartesian configuration. Now cylindrical configuration. In cylindrical configuration, it uses a vertical column and a slide that can be moved up or down along the column. The robot arm is attached to the slide so that it can be moved radially with respect to the column. By rotating the column, the robot is capable of achieving a workspace that approximates a cylinder. It contains 2 linear motions and 1 rotational motion. Now angular motion, theta along the vertical axis, translation motion, z along z direction, that corresponds to up and down motion, radial r, in or out translation. The figure will show you. This is the vertical bar which we were talking about, vertical slide. On that slide, this arm will be rotating and moving upwards and downwards. The theta will be the angular thing which is giving the angular moment to that slide bar. Now the polar configuration. It uses an arm that can be raised or lowered about a horizontal pivot. The only change in polar configuration robot is the pivot. If you compare it with that cylindrical coordinate, there is no pivot involved here, but in this case the term pivot is coming. Fine. The pivot is mounted on a rotating base. The various joints provide the robot with capability to move its arm within a spherical space, and hence it is also called as spherical coordinate robot. Okay. It has 1 linear and 2 rotary motions. The diagram itself will be showing 2 rotary, 1 linear. Which is it? Fine. Robots. And the example is that Unimate 2000 series. That is one of its examples. Now the next one is jointed arm configuration. Its configuration is similar to that of a human arm. These components are connected by two rotary joints corresponding to shoulder and elbow. A wrist is attached to the end of forearm, thus providing several additional joints. The example is model 776, commercially used one. And in that jointed arm there is one robot called SCARA. So it's using the figure you can see there are this rod, the pivot, and the angular arms we are giving, angular motions also we are giving. It's a special type of jointed arm configuration. SCARA, SCARA, what it stands for? It stands for Selective Compliance Automated Robot Arm, or Selective Compliance Articulated Robot Arm. It is similar to jointed arm except that the vertical axes are used for shoulder and elbow joints to be complemented in horizontal direction vertical insertion task. So that's how all these types of robot and automation we discussed. Now in the next chapter we'll go for sensors. Thank you.